आइए हम सुने विज्ञान की अनकही कहानियां।
Meet Dr. S.S. Thakur, decoding Himalayan rocks to predict earthquakes, uncover sustainable resources, and unlock Earth's climate secrets, proving how ancient geology shapes humanity's future.
Myself, Dr. S.S. Thakur. I am a scientist in Vadia Institute of Himalayan Geology, and my specialization is on metamorphic geology. I work on the tectono-metamorphic evolution of Himalayan rocks. My current research area is the Northwest Himalaya, where I have taken up the area of Garhwal Himalaya, Uttarakhand, as well as the Satluj Valley in Himachal Pradesh. My research area consists of higher Himalayan crystalline rocks. These rocks are high-grade metamorphic rocks. Actually, when the Himalaya originated, the central part of the Himalaya, which is the core of the Himalayan erosion, exhumed from the mid-crustal depth, and these rocks have attained the high pressure and temperature condition. My job is to thermodynamically analyze these rocks and find out the pressure and temperature condition of these crystalline areas. Basic issue of the Himalaya is that everyone knows that Himalaya is exhuming, or its height is gradually increasing time by time. So one has to say how the Himalaya has reached up to this level. So the reason behind is that the collision of Indian plate with the Chinese plate, or better to say the Eurasian plate, that in between that whatever meta sediments were there, they were exhumed. The exhumations, these exhumations, how we determine how much altitude it has attained and from how much depth these rocks has come up. To study these things, we do the metamorphic study. In this metamorphic study, we apply the thermodynamic modelings, and by this thermodynamic modeling, we calculate the pressure and temperature condition. Pressure and temperature condition say about how much depth the rock has gone, at what temperature it has attained, and how it has exhumed on the surface. If you study the metamorphic rock, you can say that the area is more vulnerable for breaking down the rock or not. If you have a high grade rocks, it will be more stable. If you have a low grade rocks, it will be brittle. It will break more easily. River will erode easily. At the same time, if you have a high grade rock, if high grade rocks are mafic rocks, if those are mafic rocks, so there is a chance that all these ore bearing minerals may form there, and they can be used for the ore extraction. I did my PhD from IIT Bombay, and in the IIT Bombay during my PhD works, I studied that Sukma granulite belts in Bastar area that comes under Chhattisgarh. So there I reported first time granulite facies metamorphism in Bastar area, and it presents. I am working at Vadia Institute of Himalayan Geology, and I am taking care of the research work related to tectono-metamorphic evolution of Himalayan rocks, and there I have worked in this Garhwal Himalaya as well as Satluj Himalaya. There I reported the pre-Himalayan metamorphism in Himalayan rocks. Whereas in the Satluj Himalaya, that higher Himalayan crystalline sequence, the origin of the higher Himalayan crystalline sequence, we reported that exhumation history of these higher Himalayan rocks. So in the Garhwal Himalaya, we have postulated that this higher Himalayan crystalline sequence have exhumes from the mid-crustal depth of the Himalaya as a single rock body, as a single lithological body. But our current research says that these higher Himalayan rocks are not a single rock body, it has a two lithological bodies and separated by a shear zone that we said Badrinath shear zone. Recently we reported this one in the Garhwal Himalaya. So we says that higher Himalayan crystalline sequence of Garhwal Himalaya has evolved from a two block metamorphic rock, not a single block metamorphic rocks. And this shear zone which occur within the higher Himalaya has been reported in Nepal also and also in Sikkim. This study suggests that these higher Himalayan rocks, those exposed in the Nangwa Parvat area to the Namche Barwa area, a continuous elongated belt. It is not a single lithologically outcrop. Actually, it has divided into two parts, and those two parts are separated by the Badrinath shear zone. In the future, as far as concerned to my future research, I feel that overall tectonometamorphic evolution of Himalaya is I am looking after it. And another thing is that the thermodynamic modeling is one of the excellent research topic by which you can model the crustal rock as well as the mantle rock. So as we know that Himalaya has a root, and its root goes up to 100 to 150 kilometer depth. So it goes up to the mantle. So how the different minerals, different rock forming minerals developed with the depth. If we do the thermodynamic modelings, we can come to know how the density is changing from surface to depth, how the pressure and temperature is changing with depth. It can be predicted by this thermodynamic modeling, and I am looking forward to model such kind of things, and hope so I may be coming out with some good research or output from Himalaya. As far as concerned to that Himalayan area, from my side, Wadia Institute along with me, we have published very high ranking journals by publishing our work, and those are from Journal of Petrology. Last time 2022 we published. That publication is a good shine that actually first times from our institute we publish this paper in that high reputed journal. So this journal is normally considered as a top ranked journal in the world. Second papers we publish in Garhwal Himalaya, that has appeared in contribution to mineralogy and petrology, and this journal is considered as one of the best journal in hardcore geology. So as far as concerned to the Himalayan geology, Wadia Institute is working nicely. We are moving step by step, and we are competing with the Western world, and India is doing fine in Himalayan geology. As far as concerned to the industrial collaboration, shall I say myself or for the institute? Anything. Thing is that I am coordinating all the things. So actually, as far as concerned to the collaborations, I am looking after all the industries, and I try to introduce this industry to my scientist, and we sit together and discuss which way we can progress forward. And in the past we have worked on this highway constructions, as well as we have several meetings with the different mining companies, with our director, with our scientists, along with all the private partners.
This podcast series on STEM popularization is supported and catalyzed by National Council of Science and Technology Communication, Government of India. Produced by Media for Community Foundation. Technical support is given by Soumya Mishra.